Welcome to Lecture Online, and our next segment in physics is going to be in mechanics, and specifically in one-dimensional motion, or motion in one dimension. So we're going to start out with some basic definitions so we can work out the next stages of this theory. And so in motion, we have to take into account that we can either talk about what we call scalar quantities or vector quantities. For example, scalar quantities in motion would be distance, speed, and acceleration. Now the vector counterparts, and I have them right here, so call these the scalars and call these the vector counterparts. Instead of saying distance, we say displacement. Instead of saying speed, we say velocity. And well, acceleration, we say the same thing. Now, what is the difference between a vector and a scalar quantity? Well, a scalar quantity is something that just explains the amount, how big, how fast, and so forth. It doesn't say anything about direction. So when we talk about how far somebody's walked, we can say somebody's walked 5 miles, but we don't know what direction. So that's called a scalar quantity, and that's known as distance traveled. Instead, we can say, well, the person traveled 5 miles in a northerly direction. Now we've given both the magnitude, how big, how far he went, and the direction the person went in. So that makes it a vector quantity. And so instead of talking about distance, we talk about displacement. The displacement was 5 miles in a northerly direction, or in the x direction, or in the y direction, or in the negative z direction, whatever it is. So to illustrate that, I have a little drawing right here. Let's say that we start from x1 and we end up at x2. So how far did a person travel? Well, it depends. What if the person took this path right here? Well, the distance traveled would be the distance you travel along this path. But the displacement is simply the vector quantity from x1 to x2. So it's x2 minus x1 in the positive x direction, indicated by this quantity right here. So the displacement in this case is actually less in magnitude than the actual distance traveled. So with displacement, we only care about the final position, the initial position, and the straight line distance between them. In the distance traveled, we just simply follow the path that the person took, regardless how crazy the path is. All right, so here we have a difference. X typically is associated with how far the person traveled, so that would be distance traveled. X with a little vector symbol on top of it means displacement. Sometimes we use the letter S to indicate displacement. Sometimes we use the letter R for position vector. All right, so the same with speed and velocity. If you could say I'm traveling 30 miles per hour, but you don't say what direction, that's simply speed, that's simply a scalar quantity. But if we say we're traveling 30 miles per hour in a westerly direction, now we've given it both the magnitude and the direction. That makes it into a vector quantity. Again, the only difference would be a v without a symbol like that simply means speed. A v with the symbol on top means velocity. Now, quite often in classrooms and in textbooks, they will use the term velocity interchangeably. So they'll say velocity when they mean speed, they say velocity when they mean velocity, and sometimes it's hard to tell the difference. Usually you can tell the difference by the characterization, by the little arrow on top, or sometimes in a book they use a bold-faced letter, a thick letter, that indicates that it's a vector quantity. Acceleration is even more difficult because we use the exact same word, whether or not it's a scalar quantity or a vector quantity. But the differentiation is if we simply say I'm accelerating at 2 meters per second squared, well, I didn't tell you the direction. That means it's just a scalar quantity. If I say the book or the ball is accelerating at 2 meters per second square in a northerly direction, now I gave you magnitude and direction, now it becomes a vector. So to illustrate that a little bit more, let's say we want to talk about the average velocity or the average speed, because I didn't draw a little arrow on it, so I should really call it speed. The average speed is simply the change in the distance over time. And let's say we go from x1 to x2, starting at t1 and ending at t2, then the average speed would simply be the difference in the x2 and x1, how far did you travel, divided by the time that it took. Even if you took a roundabout path, well, no. If you took a roundabout path to get there, then the distance traveled is actually greater, and we have to take into account the entire distance. But now we're talking about one-dimensional motion, so we'll just keep it straight. As far as the vector quantity is concerned, now we're talking about velocity, and notice a little arrow on top. That means it's the vector quantity. So we do want to take into account where we started, where we finished, and we want to take the difference between them and give direction to that. So in this case, we started from x1, ended up at x2. Notice that in this case, x2 is a smaller quantity than x1 as far as positive, large x is this way, small x is this way. So notice then, since x2 minus x1 is actually a negative quantity, then the direction would be in the negative direction. So the average velocity is actually a negative quantity in this case, even though I didn't have actually put the sign down. But you can see that since this is smaller than that, let's say that this is 2 meters and this is 6 meters, then here we get 2 meters minus 6 meters would be minus 4 meters. And then the difference in time, let's say that this is 2 seconds and this is 4 seconds, then we can say that we traveled a negative 4 meters in 2 seconds. And actually, I should make this a smaller time and make this a bigger time because we're actually moving this way in time. So you could say I moved 4 meters in 2 seconds, so the average speed is 2 meters per second, but the average velocity is a negative 2 meters per second, or 2 meters per second in the negative x direction. So that's how we use terminology in motion in one dimension. That's how we make a differentiation between scalar quantities and vector quantities. And notation-wise, if it's a vector quantity, we'll put a little vector symbol on it. If it's a scalar quantity, we leave the little symbol off. Hopefully that made sense. And now we're ready to start talking about the real mechanics of one-dimensional motion in the coming videos.